Hello everyone! 4021R4 introduces a new way to handle communication disruptions between 40 server and 40 remote thanks to the QUIC protocol. Today, I'll show you how this works in a real scenario. On this Mac, I have a 40 server application running the Invoices project with a servernet network protocol. You can see the session list, the first one being the server's stored procedures session. On this second Mac, my remote application is up and running. The client Mac is connected to a central switch. The server Mac is connected to that switch, which is itself connected to the central switch. In this setup, when we disconnect the cable between the two switches, neither Mac sees itself as disconnected from the network, but the communication between the two is cut off. I open the invoice list and scroll through it a bit to pull some data from a 40 server. When I disconnect the network cable, the list stops scrolling, which makes sense since we've lost communication with the 40 server. The user can do anything but doesn't really know why. After a few minutes, depending on the configured settings, a dialog appears and I'm forced to quit. Now, on the server side, I'm going to change the network protocol for my project and switch it to QUIC. It's very straightforward, just a single click. I'll restart the 40 server. I'm going to lower the session keeper live duration for purposes of this demo. As a reminder, this timeout is 900 seconds by default, with a minimum of 60. I'll set it to 90 seconds. I connect my 40 application to a 40 server and put myself in the same conditions as before. I also open a small tool that runs locally and lets me execute 40 code. I disconnect the cable and scroll through the invoice list. The list freezes again, but after a few seconds, a watermark appears on the window to let me know it's waiting for data but the server is unreachable. The user is therefore informed of the reason the window is unavailable. On the 40 server side, the administration window shows an unreachable status for this client. In the session, you can see the new unreachable since attribute counting up the communication disruption time. Back in my client application, the window running locally is still fully functional. I load a small piece of 40 code I prepared and run it. It displays the duration of the communication disruption using the unreachable since attribute from the session command. And there we go, I can see the duration ticking up. I reconnect the network cable. After a few seconds, the application returns to its normal state and is fully functional again. Pretty great, right? On the 40 server side, the client is back to online status and the unreachable since attribute has disappeared from the session. I disconnect the network cable again to see what happens when the session keeper live duration is exceeded. The list stops scrolling. The watermark appears. I check the communication disruption duration. On the 40 server side, I can see the duration updating as well inside the session object. Now, the timeout has been reached. The session has been automatically released, and on the 40 remote side, a system notification appears, and inside 40 remote, a clear dialog is displayed. much easier for end users to understand. The system notification lets the user know that their application needs to be quit or restarted, even when the application is running in the background, as you can see here. So, this demo has shown you how the QUIC protocol in 4021R4 provides better handling of communication disruptions between 40 remote and 40 server. The approach is user-focused to help improve the perceived quality of your applications. And all of this without a single line of code. A great reason to upgrade to 4021R4 and start using QUIC.